This is the second part of the June 2015 S1 Edexcel paper. Quite unusual to, I can't remember last time they actually talked about statistical models. We might use statistical models to simplify a real-world problem, is an obvious one. A real-world problem. And make predictions are the most obvious that spring to mind here. Others, it says in the mark scheme, it says improve understanding or analyze a real-world problem or change variables, replicate easily. But those two seem to be the most pertinent here. Stats is actually all about making predictions about populations, but it's a bit strange really to have questions like this when we haven't really done much stats. We go on to S2 and S3, we talk a lot about making predictions or whatever, making inferences from a population or whatever. So a bit of a strange 2-mark question, if you ask me. But anyway, here's your answer. Right, okay, so SXY, back into a little bit more of our comfort zone. There's formulas for that. Here we go. I've got them copied there. This is the one. Don't worry about the I bit. The I means for each individual item of the formula. And we don't tend to, say, normally this bit is not that useful in actually calculating it. It's this one that's the one we want. Okay, normally. Okay, I'll say that, and suddenly there may be a question where it's appropriate to use that one, but most times it's that second one. Obviously, they both give you the right answer. It's just that this can involve a lot of rounding errors and things if we work that, if we do it that way. Okay, so let's just write it out. Let's put my answers here on the right hand side. So we've got SXY. As per it's stated in the formula just there, is sigma xy minus sigma x sigma y divided by n. So sigma xy is given in our information here, 283.8. Sigma x is also given. No, sigma x is not given, so we need to find sigma x from adding all of these numbers together. Okay, and if we do that, if we add all of those together, we get sigma x is 12. So we've got, that's 12 times by 255 all over the number of data values. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did say 10 Winter's Day, so perhaps should have seen that. Anyway, so that equals to minus 22.2. So that's SXY. And then it says find an equation of the line of best fit. Okay, now in order to get that, we need to have X bar and we also need to have Y bar. Now X bar is equal to 12 over 10, which is 1.2. Y bar is equal to 255 over 10, so that's 25.5. Okay, now if I scroll down, go down to the formula again, B is given as SXY over SXX. So we can use that to work out B in our regression equation. SXY, let's write the formula out again, over SXX. SXY is what we've worked out in the question before, divided by SXX, which is given as 10.36. So that equals, when we work it out, that gives me minus 2.14 to 3 significant figures, but it's actually a lot more than that, which I've stored on the calculator for the next part. Now to work out A, you can, well, there is a formula for it, but I'm not going to actually use the formula because it kind of makes, we really shouldn't really need it. It is there, I'll show you in a moment, but y bar must be equal, must fit, the mean point must fit onto our regression line. So y bar must be equal to A plus B x bar. So we can then therefore say that A is equal to y bar minus B x bar. And that actually is given in the formula book anyway here. Okay, but it really we shouldn't need it really. It's just a rearrangement of our line of best fit, or our regression line for the particular value y bar x bar, which must lie on our regression line. Anyway, so we've got A equals y bar, which is equal to 25.5, minus B, which is negative 2.14 with all the other stuff, times by x bar, which is 1.2. And that gives me A equals to 28.1 to 3 significant figures. So let's write our regression line through there. So y equals to 28.1 minus 2.14 times by x. Okay, so that's our regression line, and that's our answer to part C. Now, given interpretation to A is always the easier one to interpret, but if we add this as it's the line here, as it's this value here, we need to interpret it in context. Well, let's look at what the data's about. I haven't actually mentioned it really. A scientist wants to develop a model to describe the relationship between the average daily temperature and her household's daily energy consumption. Okay, so in this case, it would be the actual temperature when it's in a winter's day. It's in a winter's day as well. So the daily temperature is 0 degrees. So it will be the answer to D would be the daily energy consumption, or daily energy consumption when the temperature is 0 degrees C, freezing. Okay, it might be worth actually writing the number in. The mark scheme didn't insist on it, but it perhaps would be a good idea to write just in case. But that's the answer to part D. Then it's for part E, let's write it here. Estimate her daily energy consumption when the average daily temperature is 2 degrees C. So that's y equals to 28.1 minus 2.14 times by 2. So that equals to 23.8. Okay, and are we, just check we haven't got a problem with units. Estimated daily energy consumption, it doesn't insist on units here, but I might be inclined to write the units in. Kilowatt hours, but it wasn't more generous here. I won't worry about it. Okay, now The scientist wants to use linear regression model to predict her consumption in the summer. Discuss the reliability of using this model for summer. Well, it would not be reliable. Summer temperatures are much higher, and we cannot extrapolate. So we couldn't extrapolate the model. You might start using air conditioners or fans or things when things get higher at that point. So that's the point. So you don't have to say that. So not be reliable. Summer temperatures are much higher, and we cannot extrapolate. That would get us our 2 marks. They weren't expecting the word extrapolate here, but quite often they do. So that's why I've used it. That's why I've used it here. Okay, so let's have a look at what question 5 has in store. Okay, so this is a discrete random variable question. It's about some quiz with 5 questions, and you get 5 points for every question that is answered correctly. Sorry, with 3 questions. So 10 points for every correct answer and -5 for every incorrect answer. So it says find a probability of 15. Well, to do that, what we need to understand is it was going to be correct, correct, incorrect. But there's actually 3 ways of getting that. That could be correct, incorrect, correct, or incorrect, correct, correct. Okay, so let's just get some power into this thing. Okay, that's better. So we got 3 different possibilities of getting it, and they're all going to have the same probability because they're all independent of each other. So it's 3 times by. That's going to be the probability of answering a question correct is 0.6. So that's 3 times 0.6 squared times by 0.4. It's binomial. It's a very simple binomial case, by the way, but that's actually an S2. But anyway, that's the answer because it's correct twice and incorrect once, and we'll times them by 3. So that equals to 0.432. Okay, and then for part B, I suppose once we've got that 0.432, it might be tempting to do 3 times 0.4 squared times 0.6 to do that. Or we could do 1 minus 0.216 minus 0.432 because they've got to all add up to 1 minus 0.064. Or do both. Use one as a check for the other. Probably would be a good idea, especially if we've got time in the exam to check our answers. Okay, now so that's that one done. And then it says find a probability of scoring a total of 30 points in 2 rounds. Okay, well, again, this is a probability kind of situation here. We've got, in order to get that, we can either get a 30 and a 0, obviously, or a 0 and a 30. Or we could have 15 and 15. Okay, those are the only ways of getting it. So this together, because they're going to have the same probability, are going to be 2 times by the probability of getting a 30, which is 0.216, times by the probability of getting a 0, which is 0.288, and the probability of getting a 15 twice is 0.432 squared. So we add all of those together, and that comes to 0.311 to 3 significant figures. Okay, so that was not too bad. And then EX, well, EX is basically the sum of the products of these. So about fiddling around with this. That times that, that times that, that times that, plus that times that. So EX is equal to 30 times 0.216 plus 15 times 0.432 plus 0 times 0.288 minus 15 times 0.064. Okay, and that comes to 12. Right, now the variance of x, is the expectation of EX squared take away EX squared, this number squared. So that equals to 30 squared times 0.216 plus 15 squared times 0.432 plus 0 squared times 0.288 plus 15 squared, because minus 15 squared comes to positive, times 0.064 minus 12 squared. And if you work all that out, that comes to 162. Okay, and then we're nearly there. We've got one final bit. It says, in a bonus round of 3 questions, a team gains 20 points for every question it answers correctly and loses 5 points for every question it does not answer correctly. Okay, find the expected number of points scored in the bonus round. So it basically wants us to set up a table really for this situation. So let's do that. In a bonus round of 3 questions, a team gains 30 points for every, let's put it up here. Team gains 20 points for every question it answers correctly. So of course it could be, let's call it Y, you could get a 60 if all 3 are answered correctly. If 2 are answered correctly but 1 incorrectly, that would be 40, take away the 5, so that's 35. If only 1 is answered correctly, that would be 20, take away 2 times 5, so that would be 10. And of course, if all 3 are answered incorrectly, that would be minus 15. Okay, so then we've got probability y equals y. We can work out the probability of all of those. All correct, 60. We're working with the numbers from before. The probabilities aren't going to change because we've still got a 0.6 probability of being correct and 0.4 of being incorrect. So the numbers, it's just the scoring that will be different. 0.216. Probabilities will be the same, 0.432, 0.288 and 0.064. So then if we want to work out the expectation of y, That's equal to that times that, plus that times that, plus that times that, plus that times that. Right, let's make sure we write it out. Never just write an answer for this thing, even if you need to say your work, at least one line of work in. Minus 15 times 0.064, and that equals to 30. Okay, so there we go, there we have it. We've got one more question to do. So here we've got a slightly unusual normal distribution stroke probability question. And the first part is just reading from tables. Probability of z being greater than 1. Remember, the z distribution is got mean of 0. So we want this area here. But the tables give us a probability of z being less than 1.1. I've got the tables here somewhere. If we have a look at it. That's not very good. I'm just not doing very well today. 1.1, it's 0.8643. Okay, so PA is equal to 1 minus 0.8463, which is equal to 0.97, oh, sorry about the barking dog, which is equal to 0.1357. Now, the event B is Z is less than minus 1.9. So that's this area here. Which is, no, sorry, Z is greater than minus 1.9. Which is this area here. Well, by symmetry, that's going to be exactly the same as reading the probability that Z is less than 1.9. So that's basically the same as probability of Z being less than 1.9, which we can just read from our tables. So if we look for 1.9 on our tables, that's 0.9713. Okay, so let's look at part C. We've got it either side of, so we've got this symmetry thing going on here, minus 1.5 and 1.5. So we've got this area here. Now what I'm tempted to do is split this in such a way as to do it like this and look by the symmetry, because we know that one side here, the bit I've shaded in red there, is 0.5. So if I read the number for 1.5, let's look it over, 1.5, which is 0.9332. Okay, then this area here is 0.9332 minus 0.5. But we've got two lots of these. We've got that times 2. So that equals 0.8664. When you're reading from the tables, I think it's fine to just leave 4 significant figures in your answers like that. So that's fine, 0.8664. Right, then finally, A union C, that's interesting. Well, if you look at what we're actually doing is we're combining two of these, we're combining this result here and this result here. Now it would be, if they were mutually exclusive, it would be just adding the two together. It's just be adding this and this together, but they're not mutually exclusive, because as you can see, if I draw another diagram here, we actually have the 1.5 and the 1.5, that's the bit there, but we've got this overlap with the 1.1. So we've got this overlap, which would be A intersection C, because that's where both events occur, where Z is both in between minus 1.5 and 1.5 and greater than 1.1. So that's the intersection. So let's work that out and then use the addition rule to come up with the final answer. So working that out, well, that's just basically equal to, let's write it out first actually. So PA intersection C is equal to the probability that Z is less than 1.1 but less than 1.5. That's equal to, so greater than 1.1 and less than 1.5. So that's the probability that Z is less than 1.5, take away the probability that Z is less than 1.1. So that equals to the 1.5, which we've read already. I think it was this number here, 0.9332. Okay, and the less than 1.1, which we read before, which was that number there, so that's minus 0.8463. So that comes to 0.0869. So now to the question, PA union C, using the addition rule, is PA plus PC minus PA intersection C. Now PA is equal to the answer here, 0.1357. PC is a 0.8664. Take away PA intersection C. Oh, what's happened there? Sorry about that. If this is the first video of one of my videos you've seen, I can show you it's not always as shambolic in terms of the use of my technology here. I don't know what happened there. Anyway, A intersection C is 0.0869. Okay, I can't guarantee that there'll never be a barking dog though, because he is prone to just bark randomly. Anyway, so let's work that out. PA union C, and that's 0.9332. Okay, that's the answer for A union C. I thought this felt a bit tricky, but I don't think it's as tricky as the next bit's going to be. Now we're on to a completely separate question. It's almost like a question 7, really. To be honest, it could have easily been a question 7, because although it's on the normal distribution and probability, we're now got a completely different normal distribution, and we're given some interesting information here, and we're trying to figure out what the hell's going on. So we've got X is normally distributed with mean 21 and standard deviation 5. Okay, lovely. Right, now we want to find the value of W where this is given. So let's just do our diagram. How much is going to help, I don't know, but let's do it anyway. We've got our mean for this distribution of 21. Okay, and we've got 28 is along here. So we know that W is some value further along here, because that's what we've been given. Given that we know that it's more than 28, okay, the probability of it being greater than W is 0.625, so that will find a W where that is the case. So basically it's almost like finding where the area is 0.625 of the whole of the blue area I've shaded. Right, so let's use the addition rule, so not the multiplication rule or the rule for conditional probability. We have the probability that x is greater than W, conditional on x being greater than 28, is equal to the probability of them both being true okay, this looks pretty complicated, doesn't it? Divided by the probability that x is greater than 28. Okay, now this looks pretty complicated here, but actually this is the same as px greater than W. It's one of these cases where if this is the case, then this is definitely the case. It's kind of an event, if you like, totally contained inside the other event, in which case the intersection is exactly the same as the event itself. So that breaks down to that. So this is more, I put this just for the general case, but in this particular case it's just that bit on top. So in order to pursue, and we're given that equals to 0.625. So in order to proceed, we've got to we've got to actually work out what this is. So let's do that first. There's a totally separate question, or not a separate question, but is it different kind of thing. Probability that x is greater than 28, we transform it to the normal, the standard normal distribution by taking away the mean, which is 21, and divided by the standard deviation, which is 5. So that gives me the probability that z is greater than 1.4. Okay, I think that's 7 over 5, which is 1.4. Now, reading that number in the tables, I think my tables might have disappeared after that funny event before. I'll just see if I can find them. It's 0.9192. Okay, so, but it's 1 minus that because we want, as we've just seen, we want the upper end. So that's 1 minus 0.9192. So that equals to 0.0808. Okay, that's the number in there. I'm using tables. I'm not using calculator for these things. One day I'll figure out how that all works, but I tend to use tables. Okay, so right, so that's PZ equals 28. Now let's get back to this formula here. We can now say that x is greater than W is therefore equal to 0.625 times by 0.808. Which is 0. Oh, I think I've 0. There's the dog again. I'll try and set him up. 0.0505. So what did that tell us? Well, we're still not there yet. We're not out of the woods. This is a tough 6 months to get here. Interesting to see how the examiner's report for this. Anyway, we need to find the value W here. We've now at least found this area, which is 0.0505. Okay, now if I just, that means that this area here is 1 minus that, which is 0.9495. Okay, so we can say that the probability of x being less than W is equal to 0.9495. Okay, so now we're looking for the numbers backwards in the tables. Because we remember our transformation is for Z to W is Z is equal to, Z to X is X take away the mean divided by the standard deviation. So we've got W take away the mean divided by the standard deviation. Now we need to read the 0.9495 number backwards. If I can scroll all the way across here to have a look. We're reading it backwards. 9495. Oh, it's bang on. It'd be nice. It's, 9495, that's 1.64. We're nearly there. So now that's W minus 21 is equal to 5 times 1.64. Which is 8.2. So W is equal to 8.2 plus 21, which is 29.2. Okay, that was not easy, folks. I wonder how many people. I wonder if Edexcel realised that was going to be hard, or maybe it's me. Maybe it's not as hard as it looks. It certainly looks hard, having done all that work, isn't it? Okay. I hope you enjoyed that video. It's 37 minutes long, longer than normal. Okay. Bye.